In this video, we're going to be going through differential calculus. So let's look at our anticipation guide. By the end of this series of lessons, you'll understand the key concepts and fundamentals behind differential calculus. You'll be able to calculate derivatives, and you'll be able to calculate the gradient of a function at any given point. Okay. Now, these learning outcomes, the first one is going to go under part 1, the part 1 video, and that's this video right here. This is going to be part 2. And the third one will be covered in part 3. Okay, so let's get started. We have a field in maths called calculus. We have a field in mathematics called calculus, and under calculus we've got two main parts. We've got differential calculus and we've got integral calculus. Okay, this video will emphasize more on differential calculus and build your foundational knowledge on it. And integral is taught after differentiation, and you need sound foundational knowledge about differential calculus to do integration. Okay, so let's have a look at differential calculus. Now, the reality is there's so many different applications to it. There's many different applications. It's a very useful thing in maths and physics and almost everything. But at the moment, at a beginner level, the only thing we're concerned about is it's the application of differential calculus when we want to calculate the rates of change of a function at any given point. Okay, so rates of change, let me just explain what this means. Rates of change is just a fancy way of saying gradient or a slope. Okay, so essentially, let me say it again. Differential calculus, we're going to use to calculate the gradient or slope of a function at any given point. Okay, that's the whole idea behind this at starter level. So let's dive into an example that you're familiar with from like high school and everything. This is a linear function. It's just a straight line. Okay, let me just draw it out. You've all seen this like plenty of times in high school, and you'll recall that the gradient, in order to calculate the slope of this function, you're going to take 2 points, and you're going to substitute the corresponding x and y values into this formula right here, and it's going to give you a gradient. Okay, it's as simple as that, but it's obvious, but it's also important to note that over here, just pay close attention. Over here at this red dot, the slope looks something like that, right? Over here, the slope looks the same. Over here, the slope also looks the same, and everywhere the slope is the same. Okay, that's the nature of linear functions. So same slope, and we have the same slope throughout the function. Okay, that's just the nature of linear functions. You can take any 2 points from this function, plug them into this, and you'll get a gradient that's valid for this whole line. Okay, and that's what makes it so easy and simple. Things get slightly more complicated when we get to calculating the gradient of a non-linear function. Okay, now let me draw one out. We're going to draw out f of x is equal to x squared. It's going to be a rough sketch, so it's going to look something roughly like that. And if we wanted to find the gradient of this, right, have a look. It gets a bit tricky. So let's say at this red dot over here, I wanted to calculate the slope. Slope looks something like that. It's a flat line, right? Over here, it's slightly increasing. Over here, it's slightly increasing. It's increasing even more. Over here, it's decreasing, and over here, it's decreasing even more. Okay, this is a bit of a problem here because you see how the linear function was nice and simple. We had the same slope everywhere. The slope all looked the same. It looked like that, right? Over here, it's a bit different because the slope over here is different to the slope over here, right? And every single point has its own different slope. That's our main thing, and we can't use this y2 minus y1 over x2 minus x1 formula, because let's say if we wanted to calculate the slope at these 2 points, between these 2 points we calculate the slope, but then if we calculate the slope between these 2 points, these two slopes would be different because it's not a straight line, right? The slope is different at every point. So that's when we use this thing called derivatives, which is a really important part of differential calculus. And we basically use this to calculate the slope of this function at any given point, right? So if I wanted to calculate the slope of this function at, say, this is x equals 1, if I wanted to calculate the function right here, I can use this thing called a derivative, a method, technique, whatever you want to call it, to calculate this slope specifically. Okay, and that's just a basic, simplified, foundational differential calculus knowledge. Just keep in mind that we haven't covered things like limits. So in another video and in later separate videos, we're going to cover limits, and we'll cover more things about foundational level calculus. But at the moment, these are the most important things you need to know.